Everyone, welcome to my second lesson about dynamics. We already explained it, we already started our dynamics lesson, Newton's law, three laws, the main part, Newton's second law, F equal to ma. So we were solving some problems related to this equation. Now we will continue our lesson. Let's do one more question, then we will continue. So let's say we have a pulley. Pulley is a circular object that can easily, without any friction, can rotate around its own axis, center. And let's say we have two objects connected with a rope which is passing through this pulley. For example, this is a first object, let's say M1 mass, and this is a second object, and this pulley of course fix it to the ceiling, for example, to the something. Pulley can only rotate, it cannot move. So question is, find acceleration and the tension in the rope, or let's say find velocity of the objects after t time, for example. If you remember, we said that we need to draw free body diagram. In this problem, we have two objects, M1 and M2, so we need to draw two free body diagrams for each object. So let's start from the M1 first object. So we will assume that M1 is greater than M2. So M1 is heavy, M2 is light. So M1 will go downward, M2 second object will go upward, logically. Now let's draw forces acting on the first object. We have only two forces, its own weight and the tension upward, which is trying to stop the first object. So let's pay attention only to the first object, this one, and let's write Newton's second law for this object. So for the first object, we know that resultant force, let me write in this way, R means resultant force. Sometimes we use F, so it doesn't matter. Resultant force should be equal to ma. So let's apply this equation, Newton's second law for the first object. We know that first object will move downward with acceleration a. This is the direction of the its motion, acceleration downward. So it means weight m1g is greater than tension. That's why it is going downward. So what is the resultant force? We have two forces, m1g minus tension, y minus, because it's opposite to the weight. This is the resultant force. It should be equal to its own mass and acceleration. Now let's come to the second object. Let's draw free body diagram. Let's show all forces acting on the second object. It has its own weight, m2g, and upward same tension, because same rope, massless rope. So again, Newton's second law, resultant force should be equal to ma. This is a general equation. Now we need to apply it to the second object. Second object will go upward logically with the same acceleration. It means tension in this case bigger, greater than weight. That's why it's going upward. So resultant force will be equal to tension minus m2g. It should be equal to its own mass, acceleration. These two objects, they will move with the same acceleration because of the rope. If you shift, if you pull first object, for example, downward for the 1 meter, second object also will go upward for 1 meter, same distance because of the rope. So here, as you see, we have the two equations and the two unknowns, acceleration and the tension. From here we can solve this problem. So let me bring second equation under the first one, and let me add these two equations to each other. So tensions will be cancelled because one of them is negative. So as you see, m1g minus m2g equal to m1a plus m2a. So we can take gravity out of the parenthesis. So we will have this kind of equation. We can also take acceleration out. So acceleration will be equal to gravity here m1 minus m2 divided by m1 plus m2. So this is acceleration. So now we can go back to the one of these two equations and find tension. So it's simple. Now I will not calculate tension. I will not waste the time. So next question was find velocity after t time. So this is a motion with constant acceleration. Let's assume that initial velocity was equal to 0. So final velocity, so this will be our equation number 3. Final velocity, as you know, initial velocity plus minus at. Initial velocity equal to 0 because it was system was at rest. So acceleration times time. Acceleration we already calculated. So g times time. Here m1 minus m2, m1 plus m2. So this will be the velocity of the objects after certain time. So as you see, you need to repeat kinematics. You need to remember all previous chapters in order to understand the new chapter better or to solve the problems easily. Now let's solve problems for inclined plane. This is inclined plane, smooth, no friction, and if we put any object on this kind of inclined plane, it will move downward in this direction, as you know, because no friction. So let's consider this motion. Again, free body diagram. We have two forces, weight and normal force. If you remember, normal force is always perpendicular to the surface. So this is the surface, and the reaction force, normal force, is perpendicular to this surface. And we know that it will move in this direction and with certain acceleration. So we need to find this acceleration, for example, no friction. So it's better to choose our axis y and the x in this way. Why? Because it moves only in one direction. So there is a motion in x direction, there is no motion in y direction. That's why it's better to choose in this way. Of course, you can also choose the traditional one like this, x and y. Of course, you will get the same answer, same results, but it will take a little bit. It will be a little bit longer, and it will be a bit complex, difficult, because in this case we have a motion in x and also in y direction. But if you choose the first one, this one, then we will have motion only in x direction. In y direction, motion, velocity, acceleration equal to 0, because it cannot go upward, it cannot fly away, or it cannot enter the inclined plane. So for this reason, we will choose the this axis, y and x. So basically, it means we should draw our forces in terms of these components. So basically, if you pay attention, n, y, reaction forces, normal forces, y component equal to n, because it's exactly directed in the same way. The x component, the horizontal component for the reaction force equal to 0. Reaction force, the y component of the weight, let's say weight y, equal to mg times cosine alpha. I will try to explain this part. So let me zoom it. Let me use different color. So let's pay attention to this triangle. 90 degree. This part is 90 minus alpha. So this is the y component for the weight. because this is y direction, this is x direction, and this part is 90 degrees as you see. So this angle will be again alpha, because this plus this should give us 90 degree. So that's why y component, vertical component for the weight will be equal to mg times cosine alpha, and this will be x component. This is x component from the triangle, which is equal to this one, and it will be equal to mg sine alpha. So x component for the weight equal to mg sine alpha. But pay attention, the y component for the weight is negative because it's opposite to the y. This is the upward positive, downward negative. Now we know that resultant force in y direction should be equal to 0 because there is no motion in y direction. So let's apply Newton's second law for the y direction. So it should be like this. We know that there is no motion in that direction. It means acceleration equal to 0. From here we can say that the resultant force equal to 0. So this is the proof. And in y direction we have two forces basically, reaction force and y component for the weight, and they are opposite to each other. So n reaction force minus mg cosine alpha, this is y component for the weight, it should be equal to 0. So from here we understand that normal force, reaction force equal to mg times cosine alpha. So this part is very important. Now let's come to the motion in x direction. So resultant force in x direction should be equal to max, acceleration in x direction. In x direction we have only x component of the weight, so which is mg sine alpha. That's all. There is no any other forces in this direction. So this should be equal to max. We can remove masses, and acceleration equal to g times sine alpha. So we have only motion. We have only one motion in only one direction. So usually we don't say ax because there is no motion in y direction. So we can just say a equal to g sine alpha. So this is acceleration. Now let's talk about friction force. In general, friction force is a force that will try to stop the motion of objects. This friction force usually appears when you have a direct contact between these two objects. For example, table, and you have an object on that table. If you try to move this object, there will be friction force. There will be additional force between table and the object due to the table surface and the object surface. Actually in real life it's not smooth. That's why there will be some resistance. So some parts of the surface will try to stop the motion, and in general we call it friction force. So let me try to draw it. This is a table, let's say, surface, and we have an object on this table surface, and when you apply a force, it will move, it may move, and there will be force between these two objects that will try to stop this object, and we call it friction force. This friction force in general depends on the surface, the type of the materials. Table can be wood, it can be made from wood or plastic, iron. The object might be made from different materials. So there are so many different factors. But in general, we can use this kind of equation. Friction force equal to coefficient of friction, which basically contains information about the type of the material, the information about the surface, but it's not important for us. This coefficient you can directly use in this equation in order to find maximum friction force. Maximum, you should be careful. So this coefficient of friction force you should multiply by normal force or reaction force, which is perpendicular to the surface. Downward, for example, we have weight. This part is important. Friction force, maximum friction force equal to coefficient of the friction force times normal force or times reaction force. Don't confuse with the weight. You should not multiply by weight. Sometimes normal force equal to weight, but it doesn't mean always you can use weight instead of reaction force, normal force. This is very important. And also you should remember that this coefficient of the friction force, maximum it can be equal to 1. Maximum. So you should expect number value less than 1 for coefficient of the friction. This is a normal force, or we call it reaction force. Normal force. This is a friction force. Again, I will repeat, this is a maximum value. And this maximum value for friction force will be when it will start its motion. When you have a motion, when object slides on something, on table, on surface, then you can use this value. During the motion, if no motion, it means friction force did not reach its maximum value. So we can explain it in terms of graph, for example. Let me draw this kind of graph. This is a friction force. This is a force that we apply. This is a 0. Friction force will be 0 if you don't apply any force. And the friction force increases when you increase force that you apply on it. And it will reach its maximum value when it starts its motion. So basically when velocity becomes bigger than, greater than 0, it means friction reached its maximum value. So here at this part, no motion, or we can simply say velocity equal to 0. From here, velocity is not equal to 0 anymore because it's moving. So let's solve a simple problem. Let's start with a simple problem for the friction force. As usual, we have a smooth horizontal surface, and we have an object, and someone is applying horizontal force. Sorry, this is not smooth. This is a surface with friction, and it has a coefficient of friction, let's say, equal to 0.5. And the mass of this object, let's say 10 kilogram, and someone is applying force equal to 40 newtons. So let's study this motion. As you see, we have a force in horizontal direction, so this object can move only in horizontal direction. So we can say we can apply Newton's second law, which is the resultant force equal to ma. Since we have a motion in only horizontal direction, so this r is the resultant force in x direction. Free body diagram. Weight downward, normal force perpendicular to the surface, upward in this case, and the friction force to the left, because it will try to stop this object. So resultant force in x direction equal to force minus friction force equal to mx, because this is a motion in horizontal direction. This is also x. So as you see, first we need to calculate, we should estimate friction force. So we know that maximum value for friction force equal to coefficient of the friction times normal force. For this case, normal force equal to weight. Let me prove it quickly. We know that resultant force in y direction should be equal to mass times acceleration in y direction. And we know that logically there is no motion in y direction, so acceleration equal to 0. So resultant force in y direction should be equal to 0, which means we have two forces in this direction, so normal force upward minus weight downward, and this should be equal to resultant force equal to 0. So from here, normal force equal to weight. So friction force equal to coefficient of friction force times normal force, which is weight. Be careful for this case. So this is the maximum friction force, of course, which is 0.5 times 10 kilogram times gravity approximately 10. So friction force equal to 50 newtons. Maximum it can be equal to 50 newtons. So let's come back to this equation. Force times friction force equal to MA, friction force 40, force 40, friction force maximum it can be 50. So as you see, the force that we apply is less than maximum friction force. This means it will not move. So be careful, this is a maximum friction force. It can be maximum 50. For this problem, we are applying force less than maximum friction force. It means it will not move. It will not move. So basically acceleration equal to 0. It means force minus friction force equal to 0. So friction force equal to force, which is 40 newtons. So for this problem, friction force equal to 40, and this object will not move. Now let's consider motion on an inclined plane, but with friction force. Coefficient, let's say, equal to mu. Free body diagram, weight, normal force perpendicular to the surface, and the friction force. As we mentioned before, it's better to choose axes in this way. And we can rewrite weight in terms of components. This component will be equal to mg sine alpha. This component will be equal to mg cosine alpha, as we mentioned before. So now we can remove the weight because we wrote it in terms of components. So all our forces are given in x and y directions, and let's say this object is moving downward. There is a motion. So resultant force in y direction should be equal to m mass times acceleration in y direction, and there is no motion in y direction because it's impossible. It cannot go upward. It cannot enter the table surface. So it means no motion in y direction. It means acceleration equal to 0. Resultant force in y direction equal to 0. In y direction we have two forces, weight, normal force, and mg cosine alpha, opposite to each other. So n reaction force minus mg cosine alpha equal to 0. So from here we understand that normal force, reaction force equal to mg times cosine alpha. This is very important because we need this normal force for our friction force. Now let's come to the x component. The resultant force in x component should be equal to max. in x direction we have two forces, mg sine alpha and opposite direction friction force. So resultant force equal to mg sine alpha minus friction force equal to max. Since we have motion only in x direction, so we can just say ma. And we are assuming that there is a motion, it's moving, so friction force reached its maximum value, which means we can use this equation. So normal force equal to mg cosine alpha. So we can just simply continue. Mg cosine alpha equal to ma. We can remove masses. So from here, acceleration equal to gravity sine alpha minus mu cosine alpha. With this acceleration, it will move downward. One problem, and this will be your classwork. We have a table. The edge of the table. Here we have a pulley which can freely rotate. Here we have a M1. Here we have a second object M2. They are connected with a massless rope. Here we have a friction which is equal to 0.2 coefficient of friction. M1 equal to 10 kilogram. M2 equal to 2 kilograms. So find acceleration and the tension